So, I'm speaking from Chicago. So, good evening, everybody. Good morning for people who are somewhere else in the world. And my name is Taimur Mohammed Khan. I'm happy to present my paper, Three-Stage Narrative Analysis, Plot Sentiment Breakdown, Structural Learning, and Concept Detection. The authors of this paper are Taimur, myself, Ramoza Ahsan, and Mohib Hameed. Uh, Starting with authors, I'll start with myself. So I was recently graduated from Illinois Institute of Technology, situated in Chicago, USA, and I completed my master's in data science. And currently, I'm working as a data analyst, and I'm also a part-time instructor. And the subjects I usually teach is AI to healthcare professionals. So basically, students who are currently in their associates in their allied healthcare fields. So what I do is I teach them the basics of AI. And if I talk about my research interest, they are basically categorized into three or four categories. One is AI in healthcare, NLP, which this specific paper is about, and then it's data analytics. So the paper revolves around stories. As you know, narratives are central to how humans communicate and make sense of this world. And each story, whether it's a movie, a novel, or a speech, it actually follows an emotional journey. Our goal in this paper was to design a computational framework that understands these stories by analyzing three dimensions. Number one is their emotional flow, number two is their structural components, and the last one is their underlying concepts. Essentially, we are moving towards automated story understanding, which I'll explain in my future works. But from now on, I'll explain what we have done, and our actual goal is, which I'll also explain in my future work, is how emotions evolve, what and how concepts evolve in stories or in movie scripts. Jumping on to our motivation. So our motivation basically comes from a simple question. Why is story analysis still mostly manual? I know a lot of AI is being implemented, but during our research, when we research a lot of articles, a lot of industries, what we found was a lot of automation was not in place. So traditional literacy analysis is subjective, it's very time consuming, and it's also inconsistent. With advances in LLP and emotional lexicons, we can now quantify emotions, sentiments, and narrative structures automatically. The ultimate goal is to build a system that can map a story's emotional arc and the structure the same way a human critic might describe it, but objectively, we want to do it at scale. We aim to automate story understanding from how emotions evolve to what concepts emerge, as I described earlier. Going on to the research problem now. So the core research problem we tackled was how can we build a multi-stage framework to analyze movie scripts computationally. So the specific part I want to talk about is movie scripts. We only focus on movie script in our research. So if we talk about the layers, we specifically focused on three layers. Number one is the emotional patterns. It means like what is the emotional trajectory of the story. Then comes the structural roles. For example, what are the key functions like reward, tension, resolution, winning, and then comes as conceptual depth, meaning does the story carry a high concept premises or low concept, or is it a character-driven theme? So this three-layer approach sets our study apart from typical sentiment analysis and plot classification works. So the framework is divided into three sequential stages. Stage one is the plot sentiment breakdown. It analyzes emotional arcs. Stage two is the structural learning. It classifies narrative segments by their functions. And the last stage is the concept detection, which identifies thematic depth as high or low concept. If I talk about concepts, it's high or low concept is a very confusing and generally looks like it's a very vague term. But if I describe it or if I try to explain it, you can understand that by, for example, if you are watching a movie, the movie may have a high concept. For example, I'll just give an example of a movie you're watching. If you're watching your hero's movie, so the concept could be the hero saved the whole world or something like that. That's a high concept. The low concepts can be derived from specific time frames of the movies. For example, the hero married someone. That's a specific concept from a movie. So there can be multiple low concept themes in the movie, which can then make one high level concept. So that's what we meant here. Okay, now I'll describe our first stage, which is the plot sentiment breakdown. So here we focus on the emotional progress of the story. We used a custom sentiment lexicon based on the NRC-VAD model, which captures not just positive or negative sentiment. Usually, whenever we hear about sentiments, we are like, oh, it's positive or it's negative, one of the both. But it also captures the intensity and the control of the emotion. These scores were integrated into the LabMT Simple, a tool for computing average emotional valence across text segments. Then each script was segmented into equal parts and a sentiment trajectory was plotted. Finally, each story was classified into one of the six universal emotional arcs, like rise, fall, and fall, rise. Further we go, I'll show you the plots as well. And then these arcs reflect the emotional journeys that readers and audiences naturally respond to. Okay, the stage two. Stage two is the structural learning. This focuses on the narrative function of text segments. We trained a text classification model to label segments as reward, tension, punishment, or victory. This process essentially maps the structure beneath the emotion. While stage one shows the ups and downs of the emotions, stage two tells us why those ups and downs occur. For example, if stage one says there was a up, this structural learning stage will tell us that was that up because of punishment or was that up because of a victory. Together, these two stages offer a semantic and emotional map of a story. Then we jump on the concept detection, which is our last stage. This stage examines whether the story is a high concept or a low concept. High concept stories are built on a clear, universal, appealing premise. For example, what if dinosaurs were cloned, as in Jurassic Park? And those concept stories, on the other hand, are subtle and character driven, like a film about a widow coping with grief. That's a very low concept. In this paper, we laid the theoretical foundation for this stage and plan to build a computational model for concept detection in our future work. If you talk about our experiment setup, we analyzed 1,000 movie scripts from public repositories. We applied the words hierarchical clustering available in SciPy to group scripts by similar emotional trajectories. Our goal was to see if the stories with similar emotional patterns could be automatically clustered and why. And interestingly, films as different as The Avengers, Blade Runner, and The Revenant fell into comparable clusters, which actually demonstrated that the shape of emotion can be universal even when the stories are not same. So that was an interesting finding in our research. And now I'll share with you some plots. So what these plots represent is the sentiment plot for different movies. So the first plot you can see is for the Avengers. And as you see, there are ups and downs, emotional ups and downs throughout the movie. And as we see, the score is increasing as the movie is progressing. If you look at the Blade Runner, the highest score you can see is in the middle. And if you look at the Revenant, the highest score is in the start. So the difference between these three is it's very simple. The overall generalization is the same. The emotional scores go up and then down, then up and then down. You can see for all these three movies. But one different thing we can observe is that the highest score is achieved at the end of the Avengers. For Blade Runner, it's in the middle, and for The Nevenant, it's in the start. Okay, interestingly, very different films, and these all show comparable emotional rises and fall, as I talked about. So let's dive into discussion and insights. So from this clustering, we observed several key insights, which I just shared, but I'll go through those again. The emotional arcs across films tend to exhibit universal patterns. Story may differ in content, but their emotional structure is surprisingly similar. Secondly, these results validate existing theories, like different theories like Freytag's pyramid and Brooker's seven basic plots. But now with computational evidence, we can actually verify those uh, literature theories. And finally, this framework opens application in story recommendation, script writing support, and audience emotion analytics. In short, it's a bridge between literary theory and data science. So, if you talk about practical outcomes for storytellers and screenwriters, um, for storytellers and screenwriters, they can actually visualize the emotional flow of their scripts to improve pacing and audience engagement. For example, as you saw the figure, the plot, using this research, you can actually see where the emotional scores are going up in your story and where they're going down. So it is very beneficial for the storytellers. They can also identify imbalances like too much tension or is there weak resolution before even production begins. And it can also serve as a creative feedback tool during editing and writing. Let's go for the media and content platform. So beyond individual writers, this framework also has applications for these people. It can serve as the basis for emotion-aware recommendation systems, which can be used to suggest films or shows by mood and concept rather than just a genre. And I'm pretty sure platforms like Netflix or YouTube might be using it somewhere in their algorithms. And ultimately, this supports data-driven storytelling across film, gaming, and digital media industries. So I believe this research is not just academic, it has real industry potential. And of course, no research is without limitations. So first of all, our sentiment analysis is lexicon based. So that means it does not capture deep context or sarcasm. Secondly, there's some noise in the sentiment plots because movie scripts vary in length and segmentation. And lastly, the concept detection stage remains theoretical. We haven't fully automated it yet. And also, the cluster captures broad trend but can miss complex narrative relationships. These limitations guide our next steps in making the framework much, much better. Let's talk about our future work. So, for the future work, we plan to implement automated concept detection, in which we plan to use the semantic embeddings and novelty models. We also plan to apply the very, very famous Fourier smoothing to clean sentiment noise, and which will eventually, of course, result in producing clearer emotional curves. And then we also plan to combine hierarchical clustering with SOM, self-organizing maps, which will eventually, yeah, I think it will eventually help us achieve better narrative grouping. And finally, of course, we can integrate transformer-based models like BERT and GPT to capture deeper contextual sentiments. Once these steps are complete, we will be able to simulate not only how stories feel, but also why they affect us the way they do. And this will be a true intersection of AI and storytelling. In conclusion, I would like to summarize. We developed a three-stage framework combining sentiment, structure, and concept layers. We then demonstrated that diverse movie scripts can share common emotional arcs, and our results were validated through clustering of over 1,000 scripts using a custom NRC-VAD lexicon. This research also lays the foundation for AI systems that can interpret and even generate human-like stories in the future. In essence, we are teaching machines not just to read words, but to also understand emotions and narratives. Below here is my contact information, my email, taimurmohammadk@gmail.com. My phone number is right here, and you can also connect with me on my LinkedIn. My username is TaimurMK, TAIMURMK. If you have any questions about the paper, about the research, about the future implications, or if anybody wants to connect with us and work on this proposed research with us in the future, they are free to do so. They are free to contact me through any of these methods. Thank you so much. I thank you all for listening very attentively. And on behalf of my other authors, which are Ramoza Ahsan and Mohib Hameed, I thank you all. And I also thank the people who are hosting this conference. You guys are doing an amazing job. Thank you so much. And